This video is on the volume of a pyramid with a square base like this right here. And so in this video I'm going to find the volume of this pyramid by dividing the pyramid into thin slices like this. So here's the pyramid again. The base here is a square and the length of the base here is b. And then I'm going to place the center of the pyramid right here at the origin. And so the height of this pyramid will be h. And therefore this point right here will be 0h. And then this point right here, which is from here to here, is half of the length of the base. So the point right here will be b over 2, 0. And then to find the volume of this pyramid, I'm going to slice it into thin slices like this. And if we divide the pyramid into n number of slices, then this is one of the slices. And so let's find the volume of this ith slice. The distance from the x-axis up to the slice, let's call it y sub I. And therefore the distance from the top here to y sub I, which is right here, and be h minus y sub I. And then let's call the distance from here to the surface of the pyramid, let's call it x sub I. And now let's relate x sub I and y sub I using similar triangles right here. And so from the two similar triangles, which is this triangle and then this triangle, we have x sub I over b over 2 is equal to h minus y sub I over h. So this is what we have. And then multiply both sides by b over 2. Then this is what we get. X sub I is equal to b over 2 times h minus y sub I over h, which is b over 2h times h minus y sub I. So this is the equation that relates x sub I and y sub I. And then also notice that x sub I is half the width of the length of the base of this ith slice. And so the length of this ith slice would be 2x sub I. But x sub I is b over 2h times h minus y sub I. And then simplify, we get b over h times h minus y sub I. And so the this side right here is 2x sub I, and then this side right here is 2x sub I. And so the area for this ith slice would be 2x sub I squared, which is b over h times h minus y sub I squared. And then expand this out, we get b squared over h squared times h squared minus 2y sub I times h plus y sub I squared. So this is the area of the ith slice. Now let's find the volume of this ith slice. And next, let's divide the interval from 0 to h. Let's divide it into n sub-intervals, like this. Y sub 0, y sub 1, y sub 2, all the way up to y sub n. And then the width of each sub-interval, let's make them all the same. And so the width of the ith sub-interval, which is also the thickness of this slice right here, which is y sub I minus y sub I minus 1. Let's call it delta y. So delta y will be the thickness of the ith slice. And once again, y sub I is the distance from the x-axis up to the slice. And so this is the area of the ith slice that we saw a few moments ago. And so the volume of the ith slice is going to be the area of the ith slice times the thickness of the ith slice. And if we have an infinite number of slices, which is the sum of the volumes of the of an infinite number of slices, is the volume of the pyramid. And then we would write it like this. And so here's the area of the ith slice, and here's the thickness of the ith slice. And then here we have an infinite number of slices. And then just like before, if this limit right here exists, and then we define it as the integral from 0 to h, 0 to h. And then the integral from for y squared is y to the third over 3. And then here we get minus h times y squared. And then here we get h squared times y. And then evaluating from 0 to h. And then when y is h, we get h to the third over 3. And then here we get h to the third. And here we get h to the third. And then when y is 0, everything here will be 0. And then simplify everything, we get 1/3 times b squared times h. And therefore the volume of this pyramid with the height of h and the length of the square base is b, then the volume will be 1/3 times b squared times h. And that's the end of the video.